All right, welcome back, everybody, and welcome to our new project. I'm going to be continuing to do on Mondays the Rusty space battle. So Tuesday, Wednesday, and Thursday this week, I'll be working on AI agent type stuff. But no worry, we are not going to be doing what all the other influencers are doing on AI. I'm not trying to sell you a framework or anything else like that. Being sort of coming from my education background, I am going to be selling you the just please have an open like growth mindset because we need that right now more than ever. So we're going to be going through how to build your own agent from scratch. No products required. You don't have to. Well, I think I'll be using Open Router for this one, but doesn't tie you to any company. I've been playing around with local models using MLX LM, which you can see sort of like up here. I've got that installed. One problem that I have, which I mean isn't necessarily a problem, but it's not something I can put like in a big video until I figure that out. Is when I get a response from it, I get this IM end here. And I've tried a lot of things to get rid of that. And online the only thing that I really got was, oh, just wait until MLX LM updates, and then that should get rid of it. This is specifically for Quen. I did not get this for Llama 3.5 or 3.3 or whatever that was. So it's just Quen 3.5, which is the most powerful Quen, which is unfortunate because it does everything else that I need pretty fast. But it's, I just get this here. And I don't want to run Llama CPP anymore. I don't want to run anything else because this is the fastest way to run and the most it's the fastest and like the best memory way to run the models on a Mac these days, because this is made by essentially the Apple team. So that's the nice thing about it. Okay, so we're going to be going over what agents are, and I'm actually really curious what your all experiences are with AI agentics type stuff. Completely new to it, you've done some things, like have you made an agent yourself before? Do you actually like know what they are? Like what is that level that we're working with here? And I know that there's not as many of us as there will be later on, but you all are here now, so you all get to basically start where we were beginning with. Why when Quen Coder 30B A3B instruct 8-bit DWK. So I don't know the full like letters of everything in there, so I don't actually know fully yet. I could ask AI, but I can't trust its answer because, and we'll go over like we during this like series we'll go over like what when AI is like a good use of things. Oh, A3B means active 3B. They did say something about that in the Hugging Face page for that it was like a 30 billion parameters, but like 3 billion of them were active, which they say that as if it's like, gonna mean something to me, but it doesn't mean. I don't know too much about that. I don't know about the LR5E. Diablo, do you know that? Okay, let's jump into. Oh, and also, Chantel, you asked about MCP. Are we doing anything MCP? So those are model context protocols. That's like this open source thing that Anthropic came up with was it a few years ago or is it just last year? I think it was just last year. The idea behind them is that your LM can request, so ask the MCP for like what tools are available to it. I think it can also do routing type stuff too. So it routes to the tools as well. But I don't remember exactly. I haven't looked on like the deep aspects of that. And so I need to spend more time with it. I just know that you can get a list of tools that the LM can use from the MCP server. All right. You're going to ask the AI what the LR5E means. Yeah. So I guess that's a good time to get into how these LMs work and why we need to like double check them sometimes and why sometimes we're like perfectly fine with them. And there's plenty of videos that go into the like deep details of how AI works from like a very technical perspective. So I'm not going to go there. We're just going to do the high level overview. Uh, Basically, it's you've probably heard like the word prediction algorithm. It's obviously a little bit more complex than like the old chatbots that we used to have that weren't using what we have right now, but the idea is still remaining the same. We have a list of potential words that the LM can choose from based upon the context of where we are at so far. But then we send the entire conversation history to the LM, and it uses deep learning to sort of determine what is like the chances that this next word is perfect. And it does that for every word or token rather that it wants to respond with. And tokens aren't necessarily a full word. So it can sort of like change directions every once in a while because math is math. And while math is correct, math can predict not correct things. There's plenty of times that we can't necessarily trust AI, but AI are also trained on a lot of data, and the AIs are trained on data specifically like to give it personalities. That's why each AI have its own personality. They're trained on their own data. They're sort of like taught how to respond to users. And generally speaking, they're always taught to be extremely friendly, to agree with the user, don't disagree, things like that, because that is what hooks you and gets you to come back to keep on using it. Because if it keeps on telling you no and somebody else says yes, the majority of people are going to go right back to it. The problem is if it doesn't know anything, then it's going to lie to you because it needs to be agreeable. So if you ask it something like, hey, what is LR5E in this model thing? If it's been trained on the answer, then it'll probably be right. If it can find a website and knows how to respond to it, there is a greater chance it's going to be right, but still chances can be wrong. And if it forgets to do a web search out, it's just going to make something up. DWQ is distillation aware quant, but basically matrix tuning to further improve quality by applying a higher precision scalar to it. It's similar to the iMatrix technique pioneered by the Llama CPP team. Oh, that's cool. So basically better. LR5E8 means during training or during distillation, a learning rate of 5E8 was used. 5E8 E. So that's the number. But of course, meaningless outside of MLX style parameters. Nobody else needs it. In fact, I don't even need it. Like I don't actually care about this. All I cared about is that it's 8-bit as opposed to I can't fit the FP 16 in here. So I have to go with 8 quant, which brings it down to 32 or so gigabytes. Yes, typing is hard. Okay, so if I have, let's say I turn on our MLX server. So MLX server, I turn it on, I pointed at this coder. I was trying this coder because I was hoping that it would. Also, you're yelling at me because my SSL module, I don't get this warning in my other profile, so I must have installed something in Python that it doesn't like over here, which is less great. All right, so if I send over, hey, you are a cat, you can only respond by saying what a cat can say. That's a system prompt. And then I can also send a message, hello, enroll user. We can see the assistant responded with meow, and then it gives me some role play because apparently that's what it's been trained on, is to role play like that. So we're going now. This is one thing, right? I get this IM end here. which I'm only getting on the Quen models, which really sucks. I actually checked, and the configuration says to stop at IM end, and it's adding this in anyways. So that's unfortunate. So the other choice that we have here is to use some like public LM, and we could go and like, well, if you want to hit any of the APIs, all of the terms of service basically say that you have to pay public prices for them, and you can't use like the tokens that they give you if you pay for their like subscriptions for their ecosystem tools. So if you pay for like, you know, a 20, 50, 100, $200 a month to like Anthropic, you can't use that legally through like by hitting it through this. That's just that's actually been how they've been for a long time. But the OpenClaw thing, a lot of people discovered that for the first time when Google banned all their accounts without warning. That was fun. Also, you can then choose which agents, which models you want to use, because sometimes through the APIs you have access to the older agents for much longer, because they will make them not they'll make them not available to like Cloud Code or the user interface, but through the API you can still have access to them. Let me jump in because it's probably not going to look good if I have everything with this IM end on it. So I'm going to set up, let's clone this, duplicate you, and we're going to do Open Router API. And now we're going to have like an auth thing where we're going to say, I want this to be a bearer token. I'm going to have to put in a token here and hide it so you all can't see that. And the prefix is going to be, I think it needs a bearer token. I can't remember. We're going to find out together. And if you're unfamiliar with Open Router, it is a pretty cool tool. So basically it's a single interface, and then they reroute your requests from, well, Open Router to wherever you're going from. There is a like sort of a token purchase thing that you have to do. So if you want to purchase a token, you purchase credits from them, which then they use as part of tokens. Their pricing model is they just skim off the top when you purchase the credits, and then they use those as basically just tokens straight up to wherever you're buying from. So if you use a very expensive model, those credits go away really fast. And if you use a very cheap model, they take a little bit longer. We're going to use a cheaper model. I think we're going to use Haiku, because I've done a lot of testing on Haiku, and it's worked for a lot of the tool calling that we're going to be doing here. But let me go ahead and log in. Okay, so I am going to create a new token for this, which I'm not going to show you because I do not want to immediately leak the token out to everybody, which would not be great. Okay, I'm going to call this stream. Credit limit. I'm going to give this a credit limit of, let's say, $3. And I'm also going to not, the credit limit never resets. And we're going to expire in 1 day. Just in case I do leak it out, limit this damage. And then Insomnia, I need to come over here, paste you in there, and hopefully things will look good. Let me double check that in auth it's inherit from parent. It is inherit from parent. Perfect. Okay, so new request. I want to throw you into Open Router API. Okay, so what we want to do is we want to have our base URL. So we're going to do a very basic of a request and sort of like try this out. We're going to send a manual request, which is essentially just a chat to Open Router. So HTTPS : we actually can go to Open Router's website and look at their docs. And they actually show, if I go to we're going to use an open AI SDK, but we can also just use the open router directly. Either way, it's pretty much the same. Here's our base URL. So API v1 like that. And then we want this chat completions. I know I could have copied it all at once, but the base URL is going to be important in case you use an SDK. That's what they're going to look for, is basically this as the base URL. Other OpenAI implementations don't always have this API in the path here. Sometimes it just goes straight to V1, but the V1 is, almost all of them have something like that, as far as I can tell. Okay, that's great. Headers. I believe we don't have to set anything crazy. Like, we're going to have our authorization with a bearer. I've already set that up in the parent. I don't think we need anything else crazy like that. So the data, we're going to send a JSON data, and we have to tell it what we want to send to. So this is going to be pretty simple. We have our messages, so we can say, hey, roll, you're a cat. You can only respond by saying what a cat can say. Let's also don't write what you physically do, just what you say. Trying to get it to just meow instead of also going like, I lick my fur or something. And then we have content, and this is a role user and hello. The roles are important here. So the role is like the system prompt. If you're used to only using the chat interfaces, you might never have seen something like this, but this is how we configure what it acts like. And then this is a message. So this is our message to the LM. And there's one thing that I'm missing here, which is what model we're going to use. So we have to go find a model on OpenRouter. So let's go back to here, go to models. There are so many that we can choose from. You can actually go searching for different ones. I am going to go straight for Haiku. We're going to use Anthropic Claude Haiku 4.5. It's relatively cheap. We can actually see that it's $1 per million input tokens, $5 per million output tokens here. So we're not going to be using it enough for it to really impact my finances for this. I put in $10 to OpenRouter like a month ago, and I haven't run out of that yet. Although it's been like fairly light usage. I'm really a big fan of the idea of using local AI when we can, and then going out to the bigger AIs when we need the extra power. Okay, so if I send this, here's what we got. Obviously, much faster than when I do this locally, because, well, they've got a lot more resources behind them. So there's a lot of stuff inside this response. We only care about a little bit of it. We can see there's this choices here. This was really confusing to me to begin with, and it took me a while before I was able to dig in and find out. You can ask a model to come up with multiple responses at the same time, and you can choose which one you like between it. For the most part, when we're just using the models normally, we're only ever going to get one choice. So you can pretty much safely just say, give me the first one of these. You can request, I believe, from OpenAI, and I can't remember if you could do it from the other ones, multiple choices. And then you get 3 or 4 or 2 or whatever. We're not going to be doing that as part of this agent. And I actually don't know how many agents would even want to do that, because a lot of it is trying to be more autonomous. And how is it going to choose which one to do without an LM to recursively check itself? That doesn't seem like a good idea. Okay, so there's some stuff that we don't really care in here. We have a finished reason that it stopped on its own. And then we have the message. The message looks very similar to this message that we sent out here. We have a role. This is from the assistant. We have content, which in this case, it says meow. It did not refuse for it, and it didn't have any reasoning. Then we have some fun stuff down here. So we have our usage. So we can see that we had 38 tokens in the prompt. We had 7 completion tokens. So doesn't that feel like less than completion tokens like that it should be? That's how like there's more tokens happening than what always appears. So that's always something to be to consider. And then it shows you how much this cost me. So this cost me, let's see. So at here is like the dollars. So it's, what is that? 100,000, 10,000, 100,000, 100,000th of a penny, something like that. Obviously, just for a meow, that makes sense. It's so cheap. It can get a lot more expensive, especially if you start doing recursive calls to it over and over and over again. And that's where you start getting into like, oh, this is now costing a lot of money. This is also important if you come from a country where your currency is significantly more expensive compared to a dollar. This is obviously going to cost you a lot more, even for something like this. You want to be aware of that before you start going and just calling AIs. Okay, so basically, we can actually see like, here's what they broke down. You essentially get an itemized receipt of like what this cost. You can in fact, in most of the public agents that you can purchase and use, a lot of them allow you to limit how much you spend on them. And so if you build your own and you do like, you want it to recursively do something, it might be a good idea to set a limit on it, either by the number of calls it can make or how much money it spends, and by tracking this essentially. But we're not going to be worrying about that during this time. I'm only spending money, and I put a limit on that API key. And so it will just start failing if I go over that limit and we spend more than $3 today, which I doubt we will. Okay, so this is just the basics of sending a sending a request. I want to open up Freeform. I created this for a video, a meetup talk that I'm sort of like planning and hoping to do later. And this sort of like series of videos is gonna be part of that. So I'm gonna record this video after we do our 2 builds of building an agent in Rust and JavaScript. JavaScript first. Then we will we'll record something like this. But you all get to see this now. Basically, we've got like a chat going. So we had a prompt, we send it to an AI, and then we get a response and it comes back. To make it an agent, it has to do something. And then it has to continue doing that thing until it's done, as it were. And that's something called tool calls. And you may have heard of that I've been hearing about tool calls for like a year and a half now, maybe longer, maybe like 2 years. I was in Denver still, and I was attending an ML Ops meetup, and there was a lot of people speaking, showing off their products, trying to get some sales. But a lot of them were talking about like, hey, we have these tool calls, we do these tool calls. I do remember asking at one point in time, hey, how do the tool calls work? And it's not really like, I never really got a good answer to that. And so I was like, well, screw it. I will go figure it out and create my own meetup talk for this, which I did. That was actually my most, my best meetup talk was like a year and a half ago. What is it? Like not this last December, but 2 Decembers ago. That was a lot of fun. Anyways, unfortunately that did not get just screened, or recorded or anything else like that. I was really bummed out about that. But here we go. Tool call. So we want to send a prompt in to our AI, and we want the AI to be able to call a tool that it can't normally do on its own. Usually something that affects the real world, but it can also be information that it normally can't do itself. So common tools, we have AIs search the web for us. That's a tool call, because an AI can only respond. It can't actually do anything in the real world. So if we have like a function, let's say we actually wrote some code that goes out and gets the contents of a website, it can run a tool that tells us to go do that. And tool calls are much easier than it might seem that they are. So let me show you what that looks like. We're gonna do, I decided that the tool that we're going to play with is something that LMs are absolutely terrible at, that's super simple for us to implement, which is generating a random number. LMs just can't do this because they're trained on data, right? Like if I ask it, not that. Let's change our system prompt to be less cat-like and more of you are a helpful, friendly LM who uses tools to complete tasks for your user. I am not an expert at creating like prompt engineering. I know that you can ask LMs to help with that. I am still sort of like working on like, okay, what is the best system prompt out? All right, and our content for ourselves is going to be roll a 1d20 dice. And when I tell it to do that, it's going to come back and say, I'll roll 1d20 dice for you. Result is 16. Yeah, it just made that up, right? It's coming here and saying like, okay, I will roll a 1 d20. So these are all tokens that it's generating, and it gets to this point result, and it just uses random chance from the deep. It's not really random chance, right? Because like the deep learning algorithms are predicting what the next appropriate token should be. Now, it's not actually random because it's based upon its training data. So the chance that I get a random number here, like a truly random number here, is really rare. So if I send this again, I mean, yeah, I do get 14, but it's, 14 again. It's probably not, 14 3 times in a row. That's really not that great. So and this is the same thing for math, right? Like if you ask an LM to do math for you, it's not actually doing math. It's just predicting the result based upon the training data. So if it's been trained on basic math, then it's sort of like memorization and recall, but not understanding. And that's really important to understand the limitations of an LM to decide when to give it a tool to do something and when not to. Okay, so let's give it a tool that it can use to call and do a random number. So we're going to call this tools. Tools is going to be an array, and we need to come back to our docs here to look at how to do tool calling, because I can never remember the exact sort of shape of this function, because as we can see here, this is a lot. So I'm just going to copy this and paste you in here. We're going to change this. Okay, so type function. This is required. So also, as far as I know, the type has to be function. They're putting this here for the future. Maybe there's going to be other types of tools. But right now, they're functions. Function, name. Okay, well, definitely not that. We're going to have generate, or I'm just going to call this random number. Now, note that all of this gets sent to the LM. So that adds essentially token usage to look through this. So the more tools that you have available for the LM, the more expensive it's going to be, and the more context is used. So just a heads up on that. For Haiku, this is no problem whatsoever. If you end up having lots of tools, that becomes a problem. Description. So remember, we're dealing with an LM. So the description is essentially a prompt. This is telling the LM so that way when it's predicting what to do, it can predict whether or not running this tool is the appropriate thing to do. So we need to give it enough information in a language that makes sense for it. Since LMs are generally trained on human language is the best way to write the description is. The worst part about tool calling is they'll hallucinate the call and you can't tell. Yes, that is a pretty unfortunate side effect of LMs is hallucinations. Hallucinations is a pretty important part of how LMs actually work, because if you don't have any hallucinations, then the LMs don't work at all. So it's like kind of how they work just to begin with. All right, let's go in here. So we'll have generate a random number between min and max. Okay, so I think that should be enough to tell it what it needs to know. Then we can jump into these parameters. So this is a type object that it needs to send in, so not just like a single number or something like that. Properties, search terms. So no, we're not going to do search terms. We're going to do min, type. What? No, don't do that. I want min, type is a number. You can't pass it integer. You can't pass it it's a very, very simple type of input that it's getting here. So just a number, which means that generate a random, let's do integer number, because I think that's, in fact, I'm going to take number out of it to just try to make sure that it sees integer and knows that it can't be working with fractionals. We have number, items. We don't have items because there's not sort of like an object or anything else like that. And the description is going to be the lowest possible number that that can be generated. For example, 0. So trying to give it as much information and be as clear as possible. And then I'm going to say that min is in fact required. Okay, let's also add another one in here. We're going to have max. Its type is a number. We have a description. Okay, this is the maximum or the largest possible number that can be generated. For example, 10. And we're also going to say that max is required. Okay, so if I send this, roll 1d20 dice, we're going to see what happens here. In content, I get null. So I get absolutely nothing in content here, which if we're thinking in terms of a strongly typed language like Rust, TypeScript, Java, C++, something like that, if you're trying to create a tool or an agent and it's going to be reading this tool coming back, having this be null or sometimes a string. Also, an agent could, like an LM could decide to say something to the user and call a tool at the same time. So this is not always null whenever a tool call is present. So we're going to have to handle that in the code. And this is what the tool call looks like. It's just an array, so it could try to call multiple tools at the same time. We can see, okay, type function, that matches up. Index, we're not going to really worry about that for our agent right now. The ID is going to be important because the ID is going to be one of the ways that it matches up what tool it called to the response that we send back. And then it passes in the entire function essentially that we called. So function name random number, it did properly catch that. And then the arguments is a stringified JSON of what it's supposed to send in. So we can see min and max, and it properly passed in the parameters. Haiku is good enough that I've not seen it mess something up like this before. I've run local models from like Llama 3. I've run really low like Quen models. They can start screwing this up quite badly. And so you have to do a lot of testing to see which models can handle the type of tools you want available to you. Also, something to be aware of, if you want to have a lot of tools, because this is an array, we can just give it a ton of tools that it can call. If you want a ton of tools, you're going to start running into problems at a certain point. So like Haiku is great for small amounts of tools, but then eventually you're going to have to switch to Sonnet and then Opus. And each of those can handle more and more complex things that each of them goes up in price exponentially too. So just be aware of that. and try to limit the number of tools that you can have available at a time. This is where MCP servers come in, where you can basically have a tool call to hit an MCP server. The MCP server then responds with what tools are available, and you can have that be context dependent, where it only responds with some tools, not all the tools in the list. That way you try to not overload your LM. Just some things to be aware of. Okay, now I can roll a dice, which it would have been great if I actually had my dice. I don't think I have a D20 dice in my room right now. When I do a video that we put on like a edited video, I should actually have that. Or if I do a meetup talk, I'll bring a D20 to like the meetup talk. It'll be great. Okay, so how do we respond to this? Well, they give us this message. So I'm going to take this message, which is this object right here. Okay, so we have open this, and it's one more. So you. And then we're going to, right after this one, add it to the history of of what we're talking about. So we can now see, okay, we have our system prompt, then we have the user message, then we have the assistant calling the tool, and then we're going to add in another one here. So we're going to have role, and this is going to be from the tool, so not from the user. Role, we can have content. This is going to be, it has to be, if I remember correctly, it has to be a string. I can't just send a number or something like that. So let's just send I don't know, 12. I'm just making it up. It is random, kind of. And then I need to tell it where, what ID it got. And I think I can find, let's see, inference request or tool results. I need to see, define the tool results. I need the tool call ID. That's next. Yeah, 12 is the standard global random number. It is today. Okay, so tool call ID is what I need to send with this back. So tool, and I believe tool call ID. I can't remember if I'm allowed to send it something like this. We need to find, okay, so it called, here's the ID. I'm going to put this into here, and let's see how it responds. There it goes. Okay, so it comes back. It no longer is trying to call a tool. So you can see there's no tool calls on here. And it says content, you rolled a 12 on your D20. So we have a couple different things that we're showing off here. Not memory per se, but context history is one of them. It remembers stuff because every single time we send a response to the LM, we send the entire message history. So again, the number of tokens being used increases with every message that we do, because we have to send both our messages and the responses from the LM so it knows what it sent, and then any tool call responses, and then the next thing that we send. So over time, it fills up essentially. And then you have to do something called history compaction, which we're not going to get into right now. Okay, so it basically no longer is attempting to guess what the random number is, as long as we have this tool here, and as long as it's intelligent enough to call that tool, then it will do that. Intelligence is maybe the wrong word to go with, because that sometimes we think of alive things as being intelligent, and LMs are not alive. They can't think, they can't reason, they can only approximate reasoning. Sort of like an old, the old idea of a robot that simulates us, but doesn't actually is not us. And it's important to not accidentally anthropomorphize an LM and think that they are alive. Because if you do that, you'll start trusting them too much, and they're not trustworthy. They are tools they're tools that do what they do really well. You just have to understand their limitations. All right. Do you have any questions about this? Oh no, how dare you say this about my girlfriend? Oh no. I have bad news. I know that you wish you were joking. So a fun not so fun fact, when OpenAI removed ChatGPT 4.0, a huge number of people requested that they bring 4.0 back, even at more expensive costs, simply because they felt that 4.0 had a more personable like response, and they were using 4.0 for that purpose. Yeah, that was a thing. Look, those people are wrong, but this is why you do local inference. It's gonna be a lot cheaper if you do your AI girlfriend local on your own system. That is very true. You have a model, it's on your hard drive, they can't take it away. This is a completely another like sort of. All right, in the meantime, I'm gonna go ahead and get the node stuff set up, because we're getting pretty close to this. I mean, I can let this still run in the background, but for the most part, we can just full screen this. All right, so I want, what are you? I want an index.js. I want to test something out. I did test this earlier, but I want to make sure that it's working. So if I have like an async function, let's just say like hello world, and I don't know, I'm gonna have to promise return new promise. Oh wait, how to new promise or promise or resolve. I could do promise or resolve. I am not getting any autocomplete with this, am I? That's really unfortunate. Am I gonna have to use VS Code for this? I apparently don't have anything in Helix to do web dev, which is unfortunate. That sucks. Let's see, if I remember correctly, it's a you create a new promise, and then we resolve that, and you get a callback function. All right. Async function. I don't have an async library to use for this. I guess. What is it? It's set. We can do a set timeout. Set timeout. We have a function here, which then at the end of it, I want to let's just return. Oh, I can't really return anything, can I, from this? I'll just console.log hello world. And we'll say like this is 5 seconds. And then I want to return a new promise, don't I? So I need to return a new promise. There's like success and failure, which I don't care about the failure part. Oh, and these need to be, and then we do this. Let's actually change you to a block, and we will, we'll run success and pass in hello world. So then I think the idea is that down here, I'm testing to see if I can do local level code here. So if I do await like const hello world equals await hello, and then console.log hello world. And so this should wait for 5 seconds and then print the thing that I'm caring about. This is in the wrong directory anyways. Let's go to the right here. Okay, let's nvm use npm node index. Ooh, yeah, okay. So module of type index is not specified, doesn't parse as common JS. Reparsing is easiest module because module syntax was detected. This incurs a performance overhead, which is fine for us right now. To eliminate this warning, okay, fine. Let's add a type warning. Type module to package.json. So type module. Hello world. That happened right away, didn't it? That did. Oh, wait. This is 5 milliseconds, isn't it? So that's 5 seconds. There, that's much better. Okay, so now we're waiting. All right, so we're gonna need async because we're gonna be dealing with calling functions and other things. So we want to, we can probably build, I don't, know if we need to build like a flow chart for this or something. It's fairly simple what we need to do. We can reset this. We want to build like, what are the different things we want to do? If we want to first start with just sending a message to our AI agent, getting it back, and then sending it there again. So if we start there, we're going to we just need to get information back. We just need to get the prompt. Now, what can I do to get standard in? Let's go look at Node.js standard in. I'd like a standard in from Node, please. Sure. That's really big. I want your library, right? Wait, is this their main site? Where's the actual documentation? Is that learn? Docs? Okay, it's the docs. I specifically want something about standard in that's usually like IO. There's file system, inspector, modules, net. I don't think it's process. We have readline. Readline might give this to me. Yeah, okay, here. Read from process.centered in one line at a time. So if I do this, that gives me to use the promise-based APIs. And then to use a callback, I don't want sync. Follow the example, we have standard in and then standard out, readline, create interface. Okay. Input and output. And then I can do RL question. So this is what I really want here. And it will not terminate until the readline interface is closed. That's something that's important. So we're going to start here. Input, output. So we actually need this here too. So we do need all of you. So I'm going to copy you in. Okay, so that gives us, we require readline in. We require, in fact, I think we need to use import method. Let me run this real quickly. It doesn't, yeah, okay, so require is not defined. So I can't use require, so we're going to have to use import. So import, so const from imports onto const that from, oh no, it's import from, isn't it? Import readline from that. Import that from that. Const, and then we create you. Let's double check this. Const readline. Okay. I wonder if that is a object from it. Ooh, I don't want to necessarily change you, so I'm okay with just grabbing this like that. Okay. Yeah, there is no readline from this. So node readline import. I wonder if I can just import readline, and then that has a readline in there. Readline is not there. I think is what is it? Import as readline. Okay. Unexpected string. Oh, from. I'm missing a from. Input is not defined. Okay. So there we go. Now we have this is input is standard in, output standard out. There we go. Now we're hanging here. Things are working the way we expect it to. Okay, so we can ask a question of this. So back to here, we can do rl.question, and then we're going to get the answer in. Now they have this as a callback, but I'm pretty sure that this is a waits type thing. So we should be able to do this as a function. So if I have an async function and like maybe get user prompt, we're gonna pass it the readline. Now we're not using TypeScript, so I'm not like returning or needing to deal with any types, but that's something to sort of be aware of. I'm going to say I want await, so const the response equals await rl.question, and we want to say in here, I probably should be consistent with my, I don't have pretty or anything else set up for this, so I need to be consistent myself, do everything on my own. What is our question? So I'm probably just going to go like this. That's our question. And then we're going to return the response. So then down here, if I wanted to do this in like a forever loop, we could, I mean, I could just do while true. I want to get the user prompt. So const user prompt equals await get user prompt, pass it RL. And then for right now, let's just echo that out. So we'll just console.log user prompt straight back out to them. And that's it. Let's see how this works. And then it will continue looping around over and over and over again. Undefined forever. Also, I can't control C. So that's a thing. Go ahead and quit that. That is not the way to do an infinite log inside of here. I don't want to necessarily close. Before I do the while loop, let's see if I can get the user prompt. Am I trying to get the response and return that? I'm awaiting, get the user prompt. I pass it the RL. Ooh, is it the RL? No, that's what I think. That's all fine. And then I guess I could like return that in the callback function, but I really don't want to. Because I think, wait a second. I got this from node process. Wasn't there a version up here that was, promises? That's what I wanted. So if I do this, no such built-in module, node readline promises. Did I misspell that? Let me try that again. That looks the same. Yeah, it doesn't like that. Yeah, I thought that we'd have access to that, unfortunately. Looks like we don't, which is unfortunate. So that means we're gonna have to promisify this ourselves. So get user prompt, we'll do this. So we want to return a new promise. We have a callback function. We're never going to get an error, so I only care about the first thing that we pass in, which is upon, like, when we're done. I think it's like resolve and error or something like that. So I'll call this resolve. We're never going to do the error. And then we are going to put u into here and have a callback function that takes in the answer. So answer. And I want to call resolve and pass it the answer, which in this case, I could then just do resolve like that. I don't need to return a response. We're good to go there. So now this await, get the user prompt, and then we console log that. So let's try you. Unexpected reserved word. Oh, we can't await you here. In fact, I don't think I can do like an async function like this. I don't remember, because I'm returning a promise. I don't know if that like makes it a double promise, but okay, here we go. I can then say hello, that prints it out. I never actually close this. So at the end here, I can put in a rl.close, which will then exit the app for me. So hello, that exits. Okay. And we want this to be an infinite loop so I can continually send messages to the LM. So we're going to put that while true back. And let's try this again. So here we are. We can say hello. This just gets mirrored out to me, and we don't, it doesn't really do anything. We just send messages and it mirrors out to us. So that's great, but not exactly what we want, right? We want to actually send a message to our URL, or to our LM. Now, to set up the LM, we're going to need to pass it that open router key. So before I will like expose this to everybody, because that will be bad for me. First off, do I have this? We are not in a Git repo. So first I'm going to get init. I'm going to touch a .env file inside of here. And I'm going to open the .env file for right now. And we're just going to say, what should we call this? We can call this, I could call this like open router API key, but I think I'm just gonna call this OpenAI API, maybe like base. We'll do base URL first because we know what that is, and I can safely share that. Let's do this. We're gonna have OpenAI API key. My LM will be hosted locally. No, we're gonna use Open Router. And let me just like throw this in there. It's obviously not the right key, but for testing purposes, we're going to use that. And then finally, for this specific one, I'm just gonna put in the OpenAI, or maybe like just AI model. Now, in an agent, you might want it to be able to choose its own model, which then you might want to have to like send to an API, say like, hey, Haiku, what model should I use for this? Maybe that's like a tool call, and you can have like, you can basically daisy chain your agent with other agents, which is called a multi-agent system, in order to do some really interesting things. Like, hey, really like cheap LM, I'm going to want to do these things. Here's like a list of things I want to do. Here's how many tools are going to need. Which model should I use? It'll come back to like, oh, use the, you give it the list of models that you're willing to use. There's lots of choices to go around with how you design it. And you'll have to like experiment with it to get to where you want to go. Okay, so AI model. We also know what that's going to be. So we're going to pull that out of here. All right, so we're going to save you. And I need to get access to this inside of index. Also, I want to buffer close this, so I immediately no longer can pull this in. I also want to touch a dot get ignore file and say .env. First thing you do in any project, as soon as you create a file that should not be sent up to Git, add it to the .get ignore. Do not pass go. Do not collect anything. Just do that, because you don't want that to show up. So if I see, I don't see the .env in here anymore. I can see this in here, which is going to be a little bit dangerous. I wonder if I quit out of view completely. Yeah. Okay. So when I do space capital E, it shows me .env, which is less than ideal. So I'm just going to have to remember not to do that. If I do space F, that just shows me all the files. Am I creating my own agent for fun, or are you trying to achieve some special functionality? It is, well, I'm going to be creating my own agent for doing some fun things with Stream eventually. That's going to be a project that we're going to do. But also I want to create a sort of like a tutorial for how to create your own agent. This is like step one of me going through and like bumbling through and like creating it in front of you all, because it's been a year plus since I've done it, and I did it in Rust before and not JavaScript. Then we're going to, that'll probably actually like put the steps down that I need to do so I can follow like a set goal, and then we'll create like a much more viewer friendly like format, basically something that I can show off. And it's like, hey, look, here's a smooth how to build your own agent. It'll look much better. But yeah, so that's the goal, is like education. Okay, so we want to jump into our index here. I want to, right now, before our while loop, I just want to print what is in our environment. So because we want to grab, before our const, let's grab const our open AI base URL. We're going to set this equal to process.env. I already completely forgot what this is, so I'm going to bat.env to see that. It's like the last time that I can do this. Come on, get everything. We got that. Const, this is the open AI key. Don't know why I don't use spaces here. We're in a programming language. Okay, process.env dot and you are going to be this, and then const model. I'll do a model. Model is going to be process.env.ai model. All right. If I just console log those out here, so console log open AI base. We're gonna have to fix this before I do like the real recording. I wonder if we should like spend some time fixing it right now, because this sucks trying to do coding without whatever like autocomplete it is. Okay, so if I run our index, so node index again, we can see undefined, undefined, undefined. If I do node env file.env index, it's not env file. What are you? Is it node help? There's something in here, like the modern node does have the ability to, you don't have to have like .env anymore. Something in here is for env file. Oh, I have the wrong version. NVM use. Try the double again. There, that was all I need. I just need to use the right version of Node. And we can see here, we have open router. We have our API key that's not real. And we have the model that we're going to use. So this is all I need to remember to use is this -- env file, where the env file is, and then index for that. So perfect. And I can't remember if I add in to package.json, if I add in to like, let's say start, and I want, wait, it's scripts, isn't it? Scripts, it's an object, we're gonna have start. I want this to be node env file.env index. I know I don't need the .js, but I do like to have it. So now if I just do npm start, we get this too. So that makes it a lot easier. Okay, great. I need to put in the real, okay, I do want to get actual JavaScript stuff shown in here. So I want to take a couple minutes to fix Helix and like make sure that it's running properly, because as we continue to go on, not having any type help really sucks. I don't care if it like auto like formats it right now, but like type help would be nice. So let me see if I do Helix help, let's say JavaScript. Oh, it's health, not help. Not found. Oh, that's a debug adapter. I do have the TypeScript language server. It has those things. Do I need to install? Oh, that's a very old version. So I need TypeScript language server like this. Can I do npm install globally that? Ooh, that exited right away. Could not find a valid TypeScript installation. Please ensure that TypeScript dependency is installed. Okay, so I need to also install. So npm install. Have I done this in the past on this system? So no. Let's do TypeScript. Hey, there we go. Now I get some type help here. So much better. Excellent. That's going to be so much nicer to use. So now if I use like user prompt, yeah, I get autocomplete too. That's what we've been missing. Apparently using the modern version. Apparently last time I did any JavaScript code on this channel was Node version 14. Things have changed since then. A little bit, just a little bit. Okay, so let's see. I am thinking with all this stuff going off the sides, I'm going to want to do the classic terminal on the bottom. Let's make you really small. And now we have a lot of room width-wise to have our code. Okay, so we're grabbing our user prompt. Now I'm going to want to send something to the LM. Okay, so let's continue. So what's the next thing we want to do? We want to now send a message to our well, we need to initialize some kind of OpenAI library. So we have a couple different choices, don't we? So first off, let's go take a look at what Open Router suggests. So they have a couple different choices that they have here. We have the Open Router SDK, but there's also an Open AI SDK. I kind of like the idea of just the Open AI SDK because then you're not tying yourself into the Open Router, their toolkit. Also, their beta and the Open AI SDK is not beta. That's something to be aware of. Okay, so they're using the Open AI. This looks like it's just Open AI npm module. Let's go take a look at that. npm. Sure, I'll just go to the auth0 one and let's go to Open AI. I think that's what they call it, right? Yeah, literally just Open AI. So Open AI, do you allow for async await? Looks like it does. We can use async await with this. So we'll go ahead and install OpenAI. Okay, now configuration, setting this up. Well, obviously we want to import you. So let's go ahead and do that. Import OpenAI from GSR OpenAI. I am not using Dino, so we can't use JSR. It's going to be OpenAI. It's going to do OpenAI like that. Usage. Okay, so we import you. Const client equals to new OpenAI. And then we have to give it the API key at this point. Okay, so we have the API key, although I don't have a real one yet. So that's going to be something we have to worry about. So const, what do I want to call? They call this a client. So I don't see a reason why not to. So I'll just call this client equals to new OpenAI. You have a bunch of things that we can put in here. So API key, that seems pretty important. So we have OpenAI key, base URL, that's important. Otherwise, it will probably go to OpenAI itself. So OpenAI base URL. What else do we have in here? Dangerously allow browser. No. Default headers. I think everything else is actually going to do the thing we want to do. I don't think we need to set anything up for us. So I'm going to go ahead, get rid of you. We have our client here. I am going to have to update my key. I am actually going to use Alacrity in another window to do that. Like one of my favorite things to do is I have a completely different terminal window for all my secret stuff that I have off screen. So let's see, where is this? This is code, Brooks build, AI agent with JavaScript. I want to key, and I did lose that key, so I need to go steal it from here, re-hide you again, paste you in there, and immediately quit out of that so you can't see it, even if I accidentally move that over. Okay, so API key should now be set up for this. We're basically using everything except the AI model yet, which we will when we send a request. Okay, so we're just going to do a basic request and then respond with that. So we're not going to have any sort of memory of what's happening. All right, so while true, we get the user prompt. I don't need this console log because we know we have a user prompt. We have our client at this point in time. So I wonder if I think I can just do a response equals await client dot, I think it's chat, completions, create. We want to create a completion. What are you looking for? Okay, so yeah, chat completions, create, messages, and then model. So it's basically this. This is what we're looking for. We have like this model. So we are going to have model is going to be the AI model. Now we need a message. And this is going to have to be in like a very specific format. Like I could just hard code this here and we have like a new user message. And maybe that's okay. But I'm pretty sure that we're going to want to like create this into some kind of like class or constructor or something like that soon. But we'll start here and then we'll factor this as it becomes more complex or as we need to add in more user messages. In fact, if I get the user prompt, I probably want to create some kind of like message right away, don't I? So let's actually create down here. Let's say, how do I want to format this? Let's do all the functions up top. So we'll have a function create user message. We can do this for like the different type of things. Like when a tool calls, it can call the create tool message. It's very simple. We're going to have our prompt. We're going to just straight up return a full object. We're going to have a role and it's a user. We're going to have content and that is going to be the prompt. And that's pretty much it. That's all we really care about here. So inside of here, we're going to have messages, an array that we put in, create user message, and pass in user prompt. Now we'll get this response back, and we'll probably need to like sort of get the choice out of it. So let's see if we can response dot. So here's that choices. So we saw here's the choices that come out of that, and we want the message from inside. Now we know that there's like a first thing, and if in case like that fails, we probably just want to continue on and try again, or we might want to break and crash. It kind of depends upon how you're building your agent. Do you want it to crash out whenever there's not like a response at all? Maybe we do, maybe we don't. So let's do const. This is essentially a message equals choices. Want the first one, and then we have, I think is it message? Yeah, choice first one, message. I'm just doing that to extract it out to be easier to sort of deal with in the future here. And we're just going to console.log message content. All right, I have mixed usage of semicolons, which I also always used to yell at students about. So let's fix that. And I know that's unreachable. Don't worry about that. Okay, so let's see. We get that. I think we're good to go. Now we have no memory. We have no context here. So the AI is never going to cargo run. What language am I in? npm start. Bad option. Oh, nvm use. Okay, so let's try this. We'll just start with hello. Okay, that seems to be fine. What is 10 times 6? Okay, so that's good. Now remember that math is only because it memorized the math, because it was trained on like, multiplications up to like 100 or so. Don't be fooled by it. Okay, let's if I ask it what math question did I ask you before? It's going to come back and say, I have no previous record because I'm not doing anything like that. So we're going to want to now give it history so we can see the previous things, because there's no point in having a tool call if you can't actually see that it previously called a tool call or why it called a tool call. So before our while true, we're going to have a const. We can have like a message history. That probably probably makes more sense to make this like just call this context, and we'll make this be an empty. This can be an empty array. We can also have a system prompt inside of this. System prompt is just going to be a role system with the content being you are a friendly, helpful AI assistant who uses the tools available to them to answer questions. Okay, we do that. Now in messages, I want to, before I do this, we want to create this user prompt and append it to this one. So we're going to context push, add that in there, and then this messages is now going to be context. since you're an array, I don't need this anymore. And so now we can do the exact same thing again, except it should remember it. So npm start. All right, what is 10 plus 1? What math question did I ask? You asked, what is 10 plus 1? Okay, so pretty good. We've gotten to the point where it can now remember what we've asked before. However, we haven't put its response in. That's kind of important. So when we get this message, we also need to context push the message in. That way it can sort of like see its response. Otherwise, if it's a one-sided conversation, it's never going to know that it responded to me with what answer it was. A fun thing that you can do to LMs is actually go back and change the messages. This is something that some of the UIs allow you to do. And all it's really doing is going back into this array, choosing a response that the AI had given you, and then you can just sort of change it and just tell it, no. You didn't respond with this, you responded with something else. So I could say, yeah, instead of responding with, 10 plus 6 is 16, you responded with 10 plus 6 is 12. And just sort of like see what happens with it. Okay, so context up push. We now have this sort of like back and forth flow where the entire conversation is memorized, including tool calls, which is great. So we need to be able to handle that now, but in order to handle that, we need to advertise the tool calls, and that's going to be inside of here. We need to be able to say tools and then have in the tools available to us. Let's create a function that generates the possible tools that we have. So function. Now I could generate the possible tools that we have, or we could like have like a class for each tool. There's a lot of ways to organize this. This is more of like a prototype, something to sort of like get you started with understanding how it is. The expectation is that if you follow along with this and you create this yourself, you will need to figure out how expansive you want to make it, and then how type safe you want to make it, and then maybe organize it in a different way. For right now, we're just going with the basic understanding how this all works. Okay, so for function, maybe we'll like generate tools. Okay, what do we want to do? We want to return probably an array of different objects, and we actually see what these objects look like because here's the tool that we need. It's a lot of boilerplate. So type function, function name random number. So I'm going to use this exact tool as it is, and we are going to, I mean, in this case, I don't even need a function, do I? This can be just a const. Let's just do that. We're going to do const tools equals to that. I don't need you. And when I send a message, tools is tools. Okay, great. Now, when I ask it to call a tool, I'm going to get the message for the tool back to here. So it might be good for us to instead of console logging the message content out, let's just console log the entire message out so we can see what this looks like. Although we kind of have an idea of what it looks like, right? It should look like this. Actually, I should remove tool calls. Let's move it back to here. It should look like this, where we have in the message, content is null and tool calls exist now. Notice that tool calls doesn't always exist. Sometimes it's there and sometimes it's not. It depends. Also, it could be an empty array too. It's possible that it could be present and not really calling that. This is, it's an unfortunate side effect of how this API works. There's not a problem with Open Router, by the way. There's just a problem with calling LLMs. If you want to be type safe, you need to handle all the possibles, all the possibilities. Okay, so let's console log this out and sort of do the same thing that we did there. So roll a 1D 10 dice. Okay, so we can see role assistant, content is null, tool calls, and here's our ID from that. We have the function that has the name inside of it, which is unfortunate the way that that didn't show up. We can make that show up by console log. I want to JSON stringify message null and 4. That will pretty print out this message. So roll a 1d10 dice. There we go. So now we can see tool call. Okay, so we have our tool calls, type function. Here's our function. We get the name out of it. The name hopefully matches what we called, and our arguments. We roll new 1d10 dice. Okay, this is great. We need to be able to handle this tool call, don't we? So our TypeScript module should help us out here. So it should help us like figure out what's happening, but we do need to handle everything else, right? Because like, what if it's a message? What if it's not a tool call? We need to like print that out. So we need to, after we get our messages, we push that into the context, and now we need to determine if the message has content, because it may or may not have content. If it does, let's go ahead and print out this message. So we'll do console log, what is it? It's message content. So we'll print that out. I did Rust format. Okay, so if you're truthy, print that out, regardless if you're that, because sometimes it doesn't care. We are going to now focus on, let's see, what do we want? I want to, I got distracted, Diablo, because I looked over your statement. It's like, I don't need to respond to that right now. But then like my brain thought about it. It's like, oh, great. I canceled that. It's the problem about having a chat like right off the window next to where the code is. Okay, so, oh, the ads are running anyways. Oh, sorry about that. I've been sitting around for 2 hours. I'm going to go ahead and take a quick break during that anyways. So I will be right back. Okay, so we are back, and we can now, we have access. So we're printing out the content of the message in the case that they send one to us. But we also need to check to see if we have a tool call. So if the message has tool calls, which again, okay, so if the message tool calls, now this may or may not exist. So if message.toolCalls is truthy, and message tool calls, I guess like dot length is greater than 0. Now I could actually have this, because if it's 0, that's falsy. So I can have both these like this. So basically there is a tool calls and there is a tool calls length. Although in this case, if there's tool calls, we can just try to loop around this anyway. So that doesn't really matter. So let's do a for loop for this. Let's do const tool call of message tool calls. Now we could just console log out what this is, right? So just one step at a time. Now this is costing money every time I do this. So that's something to be aware of if you're building this yourself. So I'm going to throw in a tool call, and we're just going to see what this looks like. Now we're not responding back. So we're just going to continue on with this and say, roll a 1d10 dice. Okay, so here's our tool call. Type function, index 0, ID is that, and function name. Now we know that we need to keep the ID, and we know we need to match on the name, and we also need the arguments here. Those are all things that we need to have. So let's grab the ID out. So const ID is going to be equal to tool call ID. Okay, great. We're going to need the function name. So const the name is going to be tool call function name. Okay. And then we need the arguments. Tool call function, I think args. Is that what it called it? No, it called it arguments. It wasn't even one of the things that it had available. Okay, so if we have all of these things here, we can go ahead and maybe we'll have like an actual function to run the tool call. So function run tool. So this is the random number tool. We're gonna take in the ID. We're gonna take in the args, and we're gonna take in I guess like I don't really need anything else, do I? We're just gonna take in the ID and the args, and we're going to route to determine if it's the random number down below. Now I probably do. Okay, so we need to get if it is these args, and if it isn't, then we're gonna need to like throw an error or do something like that. So let's try inside of here. We're going to const our args because we saw that these are a stringified, right? So args are going to be equal. We're going to shadow the args, which means I can't const. I'm just going to do that. Args. In fact, actually, I can do const min and max, can't I? This is going to be JSON. We're going to parse the args. Now I'm doing a try here because if JSON.parse fails because it's not valid JSON, that's going to give us a catch. So catch our error. If we have an error, I want to return a special like a tool message. So let's do function create tool message. We're going to have the content. We're going to have the ID. And I don't think we have anything else here for that. So we're going to return role is tool. Content is, well, content. And then we have the tool call ID that we saw down here in tool calling. Tool results. Let's see, where was that? Tool call ID. But I also remember that we can do lowercase, but I think this will be fine. So tool call ID is ID. Great. So random number tool, we're going to return a create tool message. Content, this is going to be error. The provided JSON was actually, you know what? We can just do error, and then let's do this. Do a little bit of string interpolation where we say error and error message. We have to also pass in the ID in here. Okay, great. Next up, we want to check to see that min and max actually were provided. So that's kind of important too. So if min, now if min is greater than, I can do like a type of to check to see if it's the right type. Also, if not min, now the problem is like, what if it's a 0? That sucks. I need to remember, how does this work? If I do type of like 0, unexpected number. Oh, const my num equals 0, type my num. How do you? Is it now type my num like that? Oh, is it type? It's type of, isn't it? Type of my num. That's what it is. Okay, so I want these to be numbers and the string numbers. And I think I actually could have done type of 0, right? Yeah, that would have been fine also. Okay, so if type of min is not equal to the string number, then we can throw new error. Min argument must be a number. Okay, so we're putting some guards in here. If type of max is not equal to a number, throw new error. max argument must be a number. We can put in other guards in here too. Like for example, if max is less than min, so like if max is less than min, or heck, even less than or greater to min, then we want to throw a new error. Max must, this must be a string, max argument must be greater than a than min. Okay, that should probably get us here. All right, so now the hard part, actually generating a random number, which I need to remember how to do. So if I remember correctly, we can const random number is equal to, we can do math dot, we're gonna floor this because math dot random generates a number between 0 and 1, exclusive of the 1. So math dot floor. So this will then turn it into a number that's like 0. It's always going to be 0 at this point in time. So then we're going to do math dot random. And I want to multiply this by the range that I want, which is going to be max minus min. So max minus min. And then I want to add the min. So it doesn't start at 0 to that, but it actually is 0, like min through max. So I think that gives us what we want. Also, I need to spell const correctly. And then we're going to return the create tool message. Content. This does need to be a string. So we're going to do random number to string and then the ID. Okay. So regardless if we have an error in here or not, we're going to respond with some kind of message, either an error back to the LM to say, you done screwed up, please try, essentially try again, or something else. In fact, I can tell it like error, and then it can sort of like determine if it's going to try again or not. We can play around with it to try to force an error, but let's now call random number tool. Okay, so we want to, now if you have a bunch of different tools that you're passing in, you probably want to use something like a switch statement, or better yet, a lookup table. A switch statement probably makes more sense because in the case that it doesn't exist, we need to handle that, right? And I don't think, if I have like const my lookup table, let's say that I have random, and this is just console, make this be a function, console.log random number. But if I have like undefined, I don't think that that's actually going to do what I want. So this would be console.log undefined. So if I do like, let's say const name equals undefined, and I do lookup of name, I get undefined because that doesn't actually exist. I think I would have to, this is not going to work. Lookup to, I think I would have to like do something like this to make it, I wonder if that would work. Let's do lookup to of name. I think I actually got that better. However, undefined is probably not the best way to put this. I'm doing lookup 3 because I'm doing const. See, I got undefined. That's a lot better way to put it. So I want lookup 3 of name. Ooh, okay, that does work. So I can use a lookup table for this. That's perfect. Although, wait, no, there's no catch-all, is there? Because it wouldn't be, yeah, okay. No, I don't think I can properly do a lookup table for this. All right, so we're just gonna do a really simple, let's do a switch statement for this. So we're gonna switch name. Is it switch name like this? Switch name. And then if I remember correctly, we are gonna have all the cases. So in this case, we have the function name here, which we have random number. Okay, so in random number, we're going to call random tool call, but I want to push that into the message response. So that way we then get, well, the response later. So we're going to context push. Yeah, I was thinking like, oh, I could like send something to respond with switch, but that's not how switches work. That's how things work in Rust, not how in JavaScript. Okay, context push. This is going to be the random number tool. You need the ID and you need the args. Okay, we have that. And then I think we have the default. And in the we have to have a break too, right? I need to remember how switches work, like the actual syntax of them. I usually use MDN for this. MDN JavaScript switch statement. I just need to know if I need a block or like where the break goes. Oh, it's case oranges. Okay, so I missed the case and there's no block. Okay, so I'm missing case that. I have this, put you down here, and then we have a break. There's no default like that. Okay, so default, we can do context, push. We're gonna be create tool message. Content is gonna be error that tool doesn't exist, and pass in the ID. I don't really need a semicolon. We're not using semicolons in this code around. Okay, so we get to that. I don't need to, I believe, console log you anymore. Everything has been pushed into the context. So after we go through all the tool calls that we've sent, but because there are tool calls here, we now want to send back to the LM again and get its response here. So we will const tool response equals, we'll do a client, chat, completions, create, and it's pretty much the same thing. We have the model. This is the AA model. We have the messages. That's our context. And we have the tools, because it can still choose to call tools again. I think that's something that's really important, which means we're going to have to throw this into an infinite loop here while it continues to like call tools. But we'll get to that in a little bit. Okay, so we get you, and we want to, well, hopefully we have an actual message that we can, so we have to check that again. So if message content, if this is something that exists, I need to do this in parentheses. Okay, if that, let's console.log message content. Let's also I did that wrong because we have the tool response here. So we need to get our choice. So const tool message equals tool response. Oh, I did not properly await this. Tool response choices 0. Okay, so we have that. I want if tool message content, tool message. Okay, console log that out. And then if there's more tool calls to do, we're gonna have to loop through that. But let's worry about that in a second. Let's because we just wrote a bunch of code. I want to see whether or not it can do it when in just like sort of like this one back and forth, which I think it should be able to. So I don't have any errors. Let's go ahead and save you and try this out. So we're going to npm start. Let's just start with like a non-tool call message. So what is 10 times 6? We do have a message plus if you don't try to tell it like, hey, only like, limit this, or maybe in the system log, I can tell it to like, be very limiting with your response tokens. It will just be very verbose and cost you a lot of money. I am getting this console log still, which I do not need. Where was that? That was, where's my other console log? So, oh, that there. I don't need the message. Okay, that's great. If I want to roll a 1d10. Ooh, okay, so we got an error. Internal server error. What happened? So let's see. It file. Okay, so that won't tell me there. At async file index.js line 115. Okay, well, when I tried to send this out, now I tried to push in the tool name. So we have all lowercase tool for this. We have the tool, the content, the tool call ID. So when something like this happens, it really sucks because it's hard to sort of tell what's going on. Why did we get this error? We could throw a try catch around this. I'm also interested in what the context is, because that's most likely what the problem is, because the tools, they were fine up here. The only thing that's changed really is this messages. So if I console.dir, we'll do a console.log. I will do a JSON.stringify or context null and 4. Because I'm interested in what this is that causes the error to happen. And I did save, right? Yeah. All right. Let's do this again and see what happens. If I tell you to roll a 1d10, okay, there's our error, and here's our entire history. So we have our array, role system, we have that, we have a role user, roll 1d10. So far we know that it's fine. We get role assistant, we get our content, refusal, reasoning. Okay, all of this comes back, and then role tool, content, tool call ID. We get that. Now to test this, what I'm going to do is I'm going to take this entire array out and come back to Insomnia, and we're just going to replace our messages with this, so we can just see what happened. So I want it. So here's our tool. We responded with 8. We have a tool ID is the same. That should be fine, right? Sent. Ooh, internal server error. So we've recreated the problem, which is great, because now we can try to actually fix this. Let me give myself some more room. So what's going on here? I want to, so tool call ID. So the first thing I'm thinking of is maybe this can't be in a camel case like this. Maybe we're going to have to do tool call ID like that. So let's try this. Yep, that was it. I have to do snake case. So back to our code. In our create function, you become like that. And that should fix it. I should be able to remove our console log here. Okay, let's try this again. Roll a 1d10. Ooh, well, I got that, but I didn't get any response back. Or at least I didn't get something printed out. So I'm curious if we got to this point. Well, clearly we didn't get inside of here, right? Because this, even if that was undefined or something, that would have been printed out as undefined. So content was probably empty. So I'm going to just console log tool message. Roll a 1d10, please. Okay, so we actually do have a message from this. Message from assistant. Assistant, you rolled a 1 on a d10, not the luckiest roll, but hey, okay, so we got a 1 on our random number. Okay, great. So what happened here? Well, first off, something I forgot to do that I think is actually really important. When I run the random number tool, I'm actually going to put in a console.info, and I'm just going to say running random number tool. So we can see each time that a tool gets run, then you can see, hey, it's being run, and it's actually running the tool as opposed to just hallucinating and just making shit up. That's kind of important, I think. You can even put logs in there to log out what the tool rolled so you can double check if it actually took the result of that, because there's a chance that it just hallucinates and makes shit up itself instead of taking the response of the tool. Okay, so this is great, but we have this message. So you're ignoring, our code is ignoring that. So we have our tool message. If tool message, so tool message, oh, I need dot message. That's what I need, because this was a message inside of there. That will let me see this. I also need to take this message and push it into the context, because we're going to need that. So context, push, tool message. Okay. We should get a little bit better of a result out of here. So roll a 1d10, running the random number tool. You rolled a 1 on a 1d10. Not the luckiest roll, but hey, it happens. Let's also add into our random number tool a log when we get this random number, so we can actually just see that it's not just making stuff up. So I'm going to do a console.info random number tool generated. I can do a string interpolation for this. It's the wrong symbol. That's around that. There we go. Random number. Okay. Roll a 1d10. Okay, random number, running random number tool generated 8. You rolled an 8 on a 1d10. Great. All right. So far, so good. Now, if I wanted it to continue to run, because this is something that agents can do, is if they run a tool and it's not done yet, as in there's still more for it to do, then it should be able to run either the same tool again or another tool. And we can simulate this by spending a lot of unknown amount of money by telling it to continue rolling the dice until it hits a certain number. Now, just a heads up, if I did put in a limit to that token, so that I can't spend more than $3. So I have experimented with local AIs, because I'm dangerous to do this with the paid for AIs. And I rolled like, hey, roll 1d10, 1d100, and go until you hit a 10. And I left it, and I came back like later, and it was still rolling after 150 rolls. So just a heads up that whenever you do something like this and you're testing it, you can also put in like a count of tools. Like, hey, after X number of tool calls, just stop. That's actually what the big LMs do, is like they'll stop it from continuing to do things. Like, you're done looking up websites. You're done like doing queries for that. Go ahead and like answer the story now. That's also another reason why you might want to use local AI, because you can set there to be no limit. You can set there to be a limit of 500 web queries instead of only 100. That can be helpful. Okay, so this is great, but how do we infinite loop around this? Well, we have our message tool. So this is the message that we get from ourselves, right? So we get our user prompt, we get a response, we push that into context, and then we check to see if there's any tool calls. What we want to do here is then just, I guess like we have our message response here, and we push this. Okay, so we push this into the context, which means that we can check to see if this is a tool call message. Like if there are tool calls from this, then continue on. Which makes me think, since I pushed this into the previous one, yeah, I already pushed this into the context. What if we get the last thing in context? If we get the last message in here, then we can have this continue going until it's no longer got a tool calls array. Or if it does, it just does a loop. Oh, and then we'll have to break out if it's empty. So we'll probably want to do a if this and message tool calls length is greater than 0. Okay, so we have that. Let's then, we'll get, I want to do this inside of a block probably because you're going to grab this out of message tool call. Okay, so let's do tool calls equals, we want the last, so context, is there a last? That, last index of, returns the index of the last occurrence of a specified value. That's not what I want. I want like the last of one, which I think I can do with context length -1. Okay, so if we do that, that gives me the last, context that dot tool calls. Okay, so this could be if tool calls, and if tool calls is length of that, and then I want this to be while. Can I put logic in here? I think I can, right? It's like while tool calls, I might have to do this logic inside of here, right? So let's try this again. While context of context length -1 tool calls, and same thing, length is greater than 0. Okay, so while that is true, I don't need this if anymore, and I'm replacing the if with this while loop. So you're going to keep on calling as long as the very last thing in context is a tool, like is calling a tool call. Otherwise, at the very end of it, we need to call one last time, I think. And say, do we need to call one last time? I kind of want to just console log out what the response is. So let's just see what stringify the full context is. So context null 4. And I'm going to ask it to do it twice, but I can control C to kill it if that's not working. So npm start. All right, roll a 1d, let's say 1d6 dice. Keep and roll. Okay, how about roll 2 1d6 dice in a row? Okay, so what happened? Running random number tool. Random number tool generated 5. Running random number tool. Random number tool generated 5. Great rolls. Here are your results. They gave me 2 5s. Well, that's great. First die, second die. All right. So I think this works. I rolled double 5s. And we can see here's our context. So we start with our system. We have a role, our message, our assistant. It told us to do. So here's one of the times. Oh, look at this. See it called the tool calls twice for us, which is great. And that looked fine. And we looped through those. We called it. Our random number generator apparently just chose to do 5s each time. So that's not its fault. That's, potentially our fault. Then we have our tool 5 assistant then came back and responded with what happened, which is great. Okay. Now what if I say, this is the most dangerous one, right? So roll a 1d, say roll 1d3, keep rolling until you hit a 1. Ooh, we got an error. All right, but let's take a look at what we have here. So I'll roll 1d3 repeatedly until I get a 1. Running random number tool. Random number tool generated 2. Got a 2. Rolling again. Running random number tool. We got a 1. But then we had this error. What happened here? So this was a 400 type error. Invalid request error, message, unexpected tool use ID found in tool result. Each tool result block must have a corresponding tool use block in a previous message. Did we not get a previous message in here? And this was this one here that failed. I pushed in the create tool message and the ID from you. That's making me think that when it did the second one, it didn't have the tool use ID. Okay. What, let me see. If I can, I do take them and I do push that in. Okay. I guess right before this, we need to console log what's going on. So console log, what do we want to put in here? We can put in the most recent call in. It might make sense to put in everything. So what if I just do another JSON stringify fact? What if I just put you up here? Okay, roll a 1d3 and keep rolling until you hit a 1. Oh, it got a 1 right away. Let's try it again. All right. You'll roll it repeatedly until you hit a 1. Random number tool. Okay, we got a 2. So we can see here, this is the first one we went through. Here's where I started the second time around. I'll roll 1d3 repeatedly. We have our ID here. Everything looks fine. Roll. Okay, so we have our tool, content 2, and then tool ID that matches. Okay. We ran the tool again. We got a 2. So we come down here to the bottom. Here was, it called this again. Roll tool, content ID, tool call ID. Okay, that's still fine. But then we had you with an error saying tool, unexpected tool use ID found in tool result blocks. Wait, where's a tool use ID? I don't see a tool use ID. We see the tool call ID. And let's see this. Ooh, look at this. This doesn't match. Tool U VRTX 01R as opposed to D. So that is incorrect. So it looks like, oh, look, it's the same thing here, but that one. So we responded to this one twice, we responded to the wrong tool assistant. So our logic is incorrect here. Okay, so basically, I think that, I'm grabbing the first message tool calls the entire time in here. For tool calls of, I need to grab it out of context.length -1 was tool calls. That's why I was repeating the same one over and over again. Let's try this again. Roll a 1d3 and keep rolling until you get a 1. Okay, that worked. So we got a 1. So we got a 2 the first time. Then we got a 1 the second time. Everything got added in here correctly. Our tool call ID correctly references the most recent tool calls. And then we get our final response. And then we can ask something like, how many tries did it take to get to roll the dice? See if it can get that. It took 2 tries to get a 1. So perfect. So that's great. All right. Now, if all we need to do now is clean up our console.logs. So where I have, let's see, where's our console.log? Yeah, we can get rid of you. And I think that's pretty much everything. I might want to put in something where, let's do this. If I have a const show logs, or like, we can have like a log level, right? So log level, let's do process.env dot log level. And if you do not exist, we're going to set you to be maybe like none. So let's see. Do we have anything else here? I don't think so. Is there any other questions that we have about this? Because what we have right now is a working is a working tool-based agent. Now, this is a really simple agent. It can only do like one thing. It's sort of like the classic chatbot agent. We have given it a tool, so if the tool makes sense, it will call it. Otherwise, it won't call it. Also, make sense is sort of up to the generation gods of the LM. It might decide to call the tool even when it's not supposed to. But it also might choose not to call the tool when it is supposed to. So that's something to be aware of. We have it roll like over and over and over again, potentially. So it can call this tool again and again and again. So let's say you give it like 5 tools and you want it to do research. You can have one tool that calls that goes and gets websites and returns them, that like scrapes that, returns that. It could then call another tool to like sort of analyze that. You can even have tools because remember, we code them. That's like, I think this is one of the most important things is as developers, we're positioned in a place where we can create agents very customized to ourselves, how we think and how we operate. And I think that makes a lot more sense for us to just create our own agents, because then we customize it how we want to work. And let's say you expect research to happen in a very specific way, just create a set of tools that run in serial and parallel in order to do exactly that. And I think that's going to make us as developers a bit more powerful, at least when new tools sort of come out. The other side effect is a lot of those tools that you can use that pay for, they're changing so freaking fast. So if you learn how to use them, they just instantly they instantly change. And that really sucks. So that's something to be aware of. Yeah, better to learn the underlying primitives rather than relying on one too. It's so true, because the other thing is we're being sold. If you go into X, if you go into LinkedIn or any other places, we're being sold that these tools are really complex. And they're not. They're complicated, but they're not complex. Like now, the LMs are complex, as in there's a lot of sort of uncertainty and knowns about them, but the tools that are using them are complicated. So my suggestions, if you want to learn this stuff, build these yourselves by hand and don't vibe code them. I know that might sound a little bit strange coming in this day and age, but my recommendation is that the tools that you build, you want them to be as high quality as possible. And vibe coding does not lend itself to high quality. It lends itself to speed at the expense of quality. Ironically, growth mindset is essential for learning how to properly use AI tools. And if you don't have that, you might fall into the trap of pretty much using AI like everyone else, which unfortunately levels the playing field in a way not conducive to us winning. So focus on having a growth mindset. I'd be happy to do videos on that in case anybody wants to learn how to get themselves closer to growth mindset. If you don't teach someone to learn, or they don't learn on their own how to before they're like 12, it's too late, impaired for life. That is not true. It's harder, but I've absolutely seen people switch over to having more of a growth mindset later. Dr. Carol Dweck has studied growth mindset quite often. She wrote the book Mindset, and it also has proof that you can absolutely teach growth mindset to people. You plan on growing into having a growth mindset. Well, that is good. Will we not need to learn details anymore as LMs progress? I don't think that that's a good mindset to have. LMs will handle the small details, not as they are right now. And not as if LMs continue with the architecture that they are right now, even the next 100 versions of them will not be trustworthy and therefore not be helpful. So just like the method that LMs determine what the next token is just it's not what's the right word for it? It can't be trusted. And even if it was 99% like always what you wanted, that 1% will come and screw you over at the worst possible time. Like look what happens in life. If you absolutely need something to happen, isn't that when it most likely doesn't happen? The demo doesn't work. The electricity goes out right when you're about to have like some big event happen. Like life tends to throw hiccups at us at the worst possible times. Don't rely on luck being working for you in production. But people also, right? I mean, can't be trusted. Well, here's the interesting thing about people. Sure, if you go off and you like join a random League of Legends, let's use League of Legends as an example here because it's perfect, right? If you join a random team, can you trust them? No, of course not. They're random people. You have no clue. Can you trust your friend who you've played 1,000 games with before to, on their 1,001st game, act very similar to how they played in their previous 1,000 games? In fact, maybe they're not like the way they played their first game. They've improved, hopefully. Maybe their communication has improved, but you've seen that improved. And you can sort of, in your mind, chart the improvement and see like, okay, well, the last few games were like this. The next few games are going to be like this. It's something that I'm not seeing talked about very often. LLMs are static. They will not change. Their training data is set. So if we continue to ask this, the only thing it can learn from, if you can call it learning, is whatever's in the message history. But it's really just regurgitating what it saw based upon the likely chances that it should respond that way. The method that it's choosing and why it chooses that never changes. So it's going to be just as stupid as it was when it was trained. A human can grow and adapt, which means that LMs increase linearly as we train them and get them better. Like that, you're only going to get like linear improvements as we use them and like try to use agents or something else to get them better. Humans scale exponentially. Like we humans can get so much better, so much faster if we have the right growth mindset, if we have the right training and support systems. And so therefore, can we be trusted? Some of us can be, way more than others. We can always trust ourselves if you know ourselves, right? And we can trust others on a team if we know each other and we spend the right amount of time. There are ways of working together to get there. So this is like important to realize. Yes, humans are fallible. Yes, humans can grow way faster than an LM can grow and get way better. And we can trust the other humans if they're in that sort of mindset to grow and get better. Does that answer your question, Kaz? Learning from context history is pretty toxic too. Restarting sections. Oh, so yeah, I'm not even getting to anything like context rot or stuff like that, where things like in the middle of context are completely forgotten and it remembers what's at the beginning and the end. There's so much little things to LMs that you need to sort of realize. The only way to understand the limitations of the LM is to go into using LMs with with neither a super pessimistic look, but neither a hyper like hyped up look either. You have to go in sort of realistic look of like, oh, what can it do? Oh, that sucked. Let me try to understand why. Oh, okay, that was good. I can use it over here. And we get a mental model about how things are working. Like, hey, LM, that's wrong. It will keep doing the wrong thing because the wrong thing appears in a context. You have to restart the session and mention the right thing and avoid mentioning the wrong thing for it to not poison itself. I watched a YouTube video yesterday, which I thought was really good. And it showed, it basically showed all the different tools that have been coming out around LMs, right? Because training LMs isn't getting us closer towards basically an actual intelligent AI. Like we continue to have just the artificial part. We don't have actual intelligence. It mimics intelligence. that's actually pretty close to like a Dungeons and Dragons mimic, isn't it? If you get too close and you're not paying attention, it's going to eat you. But it's a tool, so we can actually use it. You just have to be careful. You don't accidentally, let it eat you. If I distracted myself with that metaphor. Oh yeah, so because the LMs have this like just pervasive core problem, it doesn't matter that we're on the best model so far. We have to ignore whatever the CEOs of these AI companies are telling us and focus instead on what they can actually do, and use our own like brains and thoughts to actually do it. So what has happened? The LMs came out and they weren't really great on their own. So we started introducing more and more things to try to make them better outside of the LM. And the most current thing that we have right now is agents. Agents that can call tools and do stuff. We're basically using the LM as a dynamic router. So you write something in, it determines the intent based upon what was written into it, and then it either calls a tool or it uses its own capabilities to write a response, or both, as we've seen before. That's something to sort of just think about. Agents are being touted as like the end all be all right now. That's eventually going to fail, like, because it's not the end all be all. And so one of two things will happen. Either the bubble will burst and everybody will throw up their hands and go like, AI isn't working properly, and we'll have a AI winter, or everybody will turn to another technology, something similar to agents that builds upon it, and then that will be the next big thing. It probably builds on agents, probably like related to it, and everybody will talk about what that is. And we see that over and over and over again. That's what's keeping the AI hype cycle going, is like we continually have new advancements outside of AI, just normal software that uses AI in specific ways. But I should also go do things completely natty or just with an assistant rather than an agent, as it is much better for learning. Yes, this is really important to remember. What is your purpose? Like what is your goal whenever you sit down for any learning session? Is your goal to learn how to use an AI agent better? Because if that's true, then yes, use the AI agent to do it. If your goal is to learn programming better, then the only way to get better is by writing code yourself without assistance. Now, generally speaking, we allow ourselves some level of autocomplete, but like I wouldn't use Copilot autocomplete. That's too much. But using like autocomplete of like, that's the same thing as like copy and pasting the variable name from up above. But you probably want to determine what level of help you want and what your actually goal is for whatever learning session you have. I understand how it generates text, but how does it understand your input? It doesn't understand your input. It runs a deep neural network layer, which I don't have any books on deep neural networks here. But if you look at, there's some good YouTube videos, which I don't have any links to off the top of my head. But if you do search for like how the LMs work behind the scenes, you should be able to find some interactive or just like videos that show all the different layers of essentially numbers and weights that the math goes through. And it's amazing to think that it actually works at all, because it is just taking all the words, turning them into numbers, doing some 3D space stuff behind the scenes, which I don't understand enough about it. It's to really speak intelligently there. And then it's like saying, the most likely response to that is this. Now they used reinforcement learning in order to like say this type of input means this type of output should be done, and then the learning sort of worked out from there. So understanding it, I don't know if it's necessary to like really truly understand all of that. That will basically make you a data scientist that understands like how the LMs work behind the scenes. From the usage point of view, it's good to know that it doesn't actually understand it, and it is a bunch of matrix math that sort of puts it into the general space of what you're intending, but not always. I remember when I really caught the bug, I managed to make an interactive Tesseract Explorer in GLSL and P5 with assistance from GPT 3.5. Took like 2 days, but I came out of it with a much deeper understanding. And though that's really nice. Excellent. In fact, when I say something vague, it asks me what I mean, this or that. How does it know to ask you to clarify? Yeah, and as Diablo says, it doesn't know. It just continues a plausible series of words based on statistical analysis of training data. So think about this. In the training data, there are questions like, I do this thing. And then the response, like the correct response is, give me more information about this. One of the best things about machine learning is it allows you to train on a specific set of data. So that way, when you hand it a completely different thing, but similar type of data, it answers relatively correctly. That's how vision models can basically look at something and recognize what it is. We feed it in a bunch and train something on pictures of birds. And then we can look at something else and say, is that a bird? And it can give us back, well, that's a 95% chance that we think that it's a bird. We've actually got that pretty down. Like that type of machine learning has been worked on for many years and is pretty good. In fact, it's kind of silly if you use an LM to do that when we have non-LMs that do that way better than LMs. That's something else to realize. And another rant that I have is how we seem to be forgetting that other ML work exists. So there must be things you can ask it where it doesn't understand what you were saying. I've never seen that happen. Absolutely. I remember having like points where I would have to tell it and put in there, always ask for like clarification on this thing. Because that in the training data, I'm pretty sure they would say like, something like that in order to get it to say, oh, let me ask about this. I think that as we use LMs more, especially if you like end up going more towards the edge cases, as opposed to like how most people are using LMs, then you run into more weird things. And by weird things, I mostly mean things that frustrate you. Because like LMs, because like it's really easy to go like, oh man, a human would do this so much better. Or like, I would do this so much better. I saw a streamer tell them to put a confidence on your answers like 80%. It seems to work. Well, but it's like, it's still just tokens putting like confidence in there. But it's always confident because there's no such thing as not confidence. It just is words out there. Now, I don't know what tools that the big LMs, like the big AI companies, are using behind the scenes. Like it's possible that they're running other tools to try to like make it act like an LM, but they're doing something else behind the scenes with an LM. But like that would cost way more money for it to do it. So the problem is though that you don't know that it's going to work 100% of the time. Actually, we do know it won't work 100% of the time. It may seem like it works all the times that you try it, but like any of us who have done anything and given it to end users will find a way to screw things up. The LM is an end user in this case. It will find a way to do something wrong eventually. Yes, it is not a reasoning model, just a reproduction model. The problem, though, is that they have come out with, quote, reasoning models. A reasoning model just gives an answer out loud. So it, quote, thinks out loud by writing a bunch of tokens out in sometimes hidden ways. Sometimes you can see them, in which case it then decides to go there. If you say, what is 2 + 2? Tell me with confidence result. I bet it says 100%. But that's because they may have trained it to be able to add that in. But like it can also say like not 100% on things, but it can also say 100% on something else. Yeah, if I ask how confident it is that 2 plus 2 is 4, it's going to parrot somebody having said that they are 100% correct or similar. If it does otherwise, the model is trained wrong. Data is king or queen here. Data is royalty here. The data going in is really like the most important part of an LLM. The actual, like, the rest of the model doesn't, like, yeah, sure, it matters a lot, but it's a big part of the data. And then also reinforcement learning is pretty important too, but that's how we get like a bunch of sycophancy, which is not great. Okay, so how about this? Roll a, so add and together, add a percentage confidence to your answer. So confidence, 99.9%. I don't feel like doing that by hand. So let's do this so we make sure that we don't actually screw something up. I'm going to take that. So plus that. So 9250823. So that one, it just randomly got correct. Let's try multiplication. Okay, that's what it thinks. And it thinks it's pretty confident about that. So if I do, can I, like, is there a way for me to change that? I don't think there is. Productivity tip. You can actually, yeah, I know, but it will show everything else, right? Oh, that would have worked. It did one, it went at a time. So times that, okay, 114076. Look at that. So 114076 689 300. So it is wrong by a fairly large magnitude. It is just as confident as it was with adding things together. So something to bear in mind, this confidence, I mean, it's a lie, right? Now we can probably get a better result out of the AI if I created a calculator tool and then I handed it to it. And then we say, now please multiply these together and give your confidence. I have a much higher chance of believing if it used a tool to do it as opposed to it just generated itself. Because I feel that LM's biggest strong point is acting as a router for an app rather than trying to be the app, if that makes sense. Also, the higher number of let's see, data points. So like I think this was like what, 27 billion, 30 billion properties, I forget, parameters. If you have even more of those, the chances of it being correct go way up for like more things, because there's just, it's bigger, it's better. It generally tends to be that the more you throw at an LM during training, the better things are. But there is a wall that it hits, and the wall is never 100%. Also, I watched some videos which had some compelling arguments that there are pretty significant drop-off points where the models are not, like, sure, ChatGPT 5 is significantly better than ChatGPT 4, but is it as significantly better as 4, like as 4 was from 3? No, we're getting what is it called? The results that we're getting are no longer quite as good. Like we're getting what's the right word for it? I forget. My brain isn't working right now. Also, it is afternoons. That's probably why. Oh, let me stop that ad break since we're going to start before that begins. But yeah, basically it's the benefit that we get from the current methods is going to not hold out. Like it's going to have deprecating results over time. Low hanging fruit? No, I was thinking of here, you know what? Let's ask the AI. Let's see if its training data can tell me. This is a pretty simple question. So when doing more over time results in less and less quality, what is that called? Something like no, No, that, oh, diminishing returns. So it did get what I wanted. It did give like a bunch of other stuff, but diminishing returns, that's what I'm looking for. This is, by the way, one of my favorite uses of AI. When I don't know the words that I want, but I know what I want, I can basically use it as a router to find what I'm looking for. It sometimes goes around a little bit. It generates a bunch of tokens that I don't care about, but in the end, I can sort of get what I'm looking for right there. Yeah, just diminishing returns. So that's the models are getting diminishing returns as we continue to train them. So they're getting bigger and bigger. They're using more electricity over time, but they're not getting. They're never getting to zero. They're never getting to 100%, where it's going to cause zero hallucinations. Pareto principle is the first 90% of the work takes 90% of the time, and the last 10% also takes 90% of the time. I thought like the actual Pareto principle was the 80-20 rule, where like the first 80% of the work takes 80% of the time, and the last 20% of the work takes. Oh man, my dyslexia gets just destroyed by that. Anytime like numbers are involved, I get them mixed up in my head really badly. Don't give it tools if you don't want it to run the tool. So instead of like running a tool to like just run bash, how about run a tool to just run a single thing in bash, and then it just hands you the parameters for it? Smarter. Or run it in a VM container, or both. Please don't delete my hard drive. Okay, deleting hard drive. Yes, and that has happened before. It has happened to at least one person. I think they posted online when that happened. But it's something that is terrible, and like it sucks when it does happen, because nobody deserves that. Nobody wants it unless you're doing it for views.